Hey everyone, this is Arbalo, and for this video, we're going to talk about the last video for our object-oriented programming series, which is about abstraction. And as usual with our previous object-oriented concepts, we're going to talk about what is abstraction, the definition of this object-oriented principle, and how do we implement this in Dart, what are the benefits of abstraction, or in other words, when do we use it, and why do we use it, and when do we use it. Yeah. Okay, so let's start with, of course, the definition of abstraction in the context of object-oriented programming. So when we say abstraction, it's basically is simplifying complex objects. And how do we simplify? We just expose. When we say expose, we only show, or we are revealing only the necessary features while hiding the implementation details, or basically how that feature works. It only shows what are the necessary features, but it doesn't show or reveal how it works. Okay, take note of that. What and not how. Anyway, we have an example of this. Let's say, for example, in a car class or any vehicle that you drive, usually we are only presented with the necessary features lang in order for us to accomplish our goal. Of course, the very obvious, we have the steering wheel, which is we use to drive or to manipulate the turn the vehicle from left to right. Then we also have this this handle right here, which controls when we should stop, or when to park or reverse. Then we also have the brake, which is hindi nyo makikita, but in the yung tinatapak ng paa, the foot brakes. Then we also have some features what you could use to control the windshield, the lights for turn signals. Then we also have some interfaces for other stuff like entertainment and for the aircon. And basically that's it. Of course, there are other important stuff, but these are the frequency or most common feature that's present in a car. And this is the only necessary features that are shown to us. And of course, since this is a complex object, we are not shown how it works or on the mechanisms behind this car. Because when we're going to take a look at what's inside car, it has many other components. Let's say yung steering wheel, if we wanted to check it, it's connected pa pala with these other stuff right here. Alternator, we also have radiator, the starter motor, and so on and so forth. And of course, we have the brakes right here. So yeah, again, just like in the car, we're only presented with the necessary features lang, like the steering wheel, the brakes, and so on and so forth. And the car doesn't show its internal workings or internal mechanisms. And another thing that you need to take note is, despite the differences in owner or manufacturer, most real-world objects expose the same features. And an example of that is, let's say, in an ATM machine. Now, obviously, these are different. Each ATM right here has a different owner or back. But as you notice, despite the differences in the owner, which bank company owns this ATM, they literally have the same interface or features that they are presenting to or revealing to the users. Let's say, for example, the slot to insert the credit card, the slot where the money comes from, where the money will go out. Then the buttons in order for us to choose a menu. Then we also have the screen. So yeah, each and every ATM right here has exactly the same look, no, features. No. Another thing, another example of a complex object is a smartphone. So yung mga necessary features lang that only are shown to us is, of course, the screen itself, the touch screen, the camera, the front and the rear camera, of course, the volume, the buttons to control the volume, and the power button. Now, despite the differences, so in iba-iba yung mga nito, manufacturers, we have Apple, Huawei, Samsung, and Xiaomi. Of course, each of these companies or manufacturers have their own way of implementing their smartphone. Now, we don't know how they created these smartphones or ano ba yung tsura ng circuitry behind or the electronics behind it. Basta, iba-iba talaga to, no? Implementation. So, perhaps iba yung camera dito, mas mataas yung resolution or pixels niya compared to the other phones. Pwede rin this other phone has a bigger storage. Pwedeng this one has a much faster processor kasi perhaps mas marami siyang cores compare sa ibang na mga CPUs dito sa ibang device. So, yeah. Now, how is abstraction implemented in coding? Because abstraction is just a concept, but of course, since this is a concept that can be applied to programming, how do we apply that? So let's say, let's have an analogy. For example, we have a rich guy. Kasi since he is rich, he has a mansion, and he has plenty of cars. And of course, since he has plenty of cars, we are expecting that this person knows how to drive, or he is also a driver. So, let's say a driver, whenever a driver uses a car, he only needs to know a couple of things, of course. He needs to only know how to operate the car. And ano ba yung mga possible operations or methods in a car? The driver can start the engine, the driver can drive the car, the driver can stop the engine, the driver can also brake, stop the engine, stop the car itself with the brakes, can also turn or rotate the wheels of the car. But let's say for the sake of demonstration lang, let's just focus on these three operations or methods in this car. So yeah, again, whenever a driver drives a car, yan lang yung nasa isip niya. These operations, ano may mga capabilities ng car, what the driver can do to a car. And of course, these two specific cars that he owns, let's say sports car and electric car, they can also start the engine, can also drive, they can also stop their engine. So yun. Now, we're going to convert this into a program. No? Let's say, for example, let's start with the driver. Let's say we're going to give lang a couple of attributes, say name, just to indicate lang who is the driver, and the car na he is going to drive. He's going to use to drive, no? In order for this driver to start his journey, his or her journey, and end journey. So once he starts his journey, the driver starts the journey, is going to start the engine's car, and is going to drive the car. Now, same thing also with end journey. Once the driver ends his journey, his or her journey is going to stop the car engine. And we also have a setter right here where we can allow, or the driver is allowed to switch to a different car or change his car na gagamitin niya. And by the way, I would like to emphasize lang line 43, no? Kasi in our previous video about composition, no, usually when we are declaring an object right here, it usually comes from a class, a concrete class. But this time, this is different. Kasi this one right here in particular is not a class. This is not a class. And to show you what I mean, this one is at this car right here is actually what we call as an interface. Is that then that's the first step. No? We define an interface, and when we say interface, is just a list of abstract methods. Why abstract yung mga methods niya? Is because it just simply declares what it can do, but it doesn't tell, or it doesn't have the code specific implementations on how it works. Yan lang. Void start engine, period. That's it. This again, when we say interface, this is just a list of abstract methods. Kumbaga, it just defines what it can do. Now, the next part is, of course, we have two types of cars, diba? We have the sports car and the electric car. Now, once we create those specific cars, here's what's going to happen. Now, we're going to, now just notice right here, we have an extra keyword right here about class sports car implements. Now, this is the most important keyword, and you need to take note. Implements, and then what interface it needs to implement. So in this case, car. And once we insert this keyword right here and defining or specifying any interface that we need to implement, we are mandated to override those methods that was defined or listed right here. No? Yeah. And since we're overriding, we need to now, this sports car now is mandated to provide the specific instructions when it's going to start its engine. So, diba? So in this case, pag magsa-start yung engine, yung car, is going to do this. Ito yung instruction niya, which is going to print this. And also, once the sports car drives, ito yung mangyayari. Ito yung instruction niya. Same also with stop engine. Now, how about for the electric car? Parehas pa rin, no? Again, we are using the implements keyword and specifying the interface that we need to implement. In this case, car. And again, we override all the methods listed sa interface na to and provide the specific instructions. So now, electric car also has its own implementation on how it will behave when it starts the engine. Same also sa drive. This is also how it behaves sa electric car and stop engine. Yun. Now, of course, we already have defined now the classes that we need and the interfaces, the driver and the two specific car classes. Now, let's simulate that into the actual scenario though. And let's say, for example, we're going to define a main function where first we're going to create a car object, specifically sports car, and we create a driver object, and we will name this driver as Stefan, yours truly. And the driver has a car, specifically a sports car. So that's why the car right here that we create in line 61, we include that in the constructor. And yun, we now have a driver object, and now the rich driver can now start his journey and end his journey. And it's going to print anyway. After that, let's say tapos na yung journey niya to Stephen, and he wants to start another journey, but he wants to use or switch to a different car, let's say electric car. So this time, we're going to create electric car, and we will use the setter in order for us to change the car that is using from a sports car to an electric car. And then again, we call the method start journey and end journey. Now, despite calling the same methods twice, start journey, line 63 and 71, and end journeys, line 64 and 72, it's going to render a different output, as you can see in the next slide. So yun. And we don't have issues, no? Kasi even though that in the first part, the moment we call the start journey, iba yung driver, iba yung car na ginamit dito sa line 71 to 72, iba din yung car na ginamit, electric car. And the reason why we're able to produce this output is because the electric car and sports car implement the same interface, which is the car interface. Yun. Now, I hope that na-guess na niyo yung source code natin. And let's talk about why we use abstraction. And there are plenty of reasons, but for me, the main reason is it makes our code more flexible. And what do you mean by flexible? Let's say, going back to our driver class, diba, this car right here is not a concrete class, but it's an interface. And since we are in the driver class, or any class, if a class depends or interacts with a interface, it makes our code flexible kasi now we can easily switch between different car implementations. Diba? As you saw kanina, the moment that we provide a sports car as a driver, now when it starts its journey, it's going to start engine and drive sa sports car. And let's say at some point sa program natin, we want to switch a different type of car, we can still easily do that. Again, how was we able to achieve that? Because the driver is, or this class is depending on an interface rather than a concrete class. But if this was a not flexible code, let's say for example, line 43 is sports car, and again, let's say the requirements of our program changes. Imbes na sports car, magiging electric car na. Now, we're gonna have to replace our line 43 na code. Papalitan natin from sports car to magiging electric car. And that makes our code not flexible kasi every time we change requirements, we keep on modifying or we keep on replacing this for line 43. So in order for us not to tamper or modify our code, na maging flexible siya, so yan, we redefine an interface step. So I hope that you understood that deep explanation. Now, let's talk about when do we use abstraction. The only time that we use abstraction is when we're creating new subclasses that adheres or follows the abstract interface. And let's say, for example, so far we have electric car and sports car. And let's say we have our requirements have an additional requirements that program natin that we add a self-driving car. So, yun, we can pretty much do that as long as that self-driving car implements the car interface. Another reason, or when do we should use abstraction, is when we want to flexibly swap out the components in a class or system. And just like you saw kanina, the driver can switch from different car implementations, like from electric car to a sports car. And if ever we are going to add a new subclass, let's say self-driving car, it can also switch to that new subclass. Yun. Specifically, now if we're going to apply abstraction in the actual software development, we could abstract our database repository. And let's say our database repository has create with update delete methods. So rather than relying on our application relying on a specific type of database, let's say MySQL, why not just let it interact to an interface so that we could have the flexibility to switch to different databases, let's say from MySQL, a relational type database, to a non-relational database, let's say MongoDB. Another example is when we are abstracting the payment gateway, and our gateway interface has a process payment method. And we want this payment method to be implemented through our specific concrete classes, let's say Stripe or PayPal, so that our e-commerce application can easily switch from a different payment gateway, from Stripe to PayPal. Let's say, for example, our application also needs to communicate or interact with a messaging system, and it has a send message method. So we define this in interface instead, and we let the concrete classes provide their specific implementations. Let's say email service, SMS service, and we can even add a push notification messaging. Let's say if our application expands its feature, send siya via push notification, we can do that. And lastly, abstracting AI models. If you're familiar with machine learning, usually in a machine learning model, it can predict. It's either it can predict a number or a specific classification. Let's say, for example, it can predict the price for the next month of a certain rice. No, it can predict, or it can be able to predict the type of fruit, based on the picture. Ano bang klaseng fruit to? So there are many types of AI models. Now, rather than your application depending on a specific concrete class, let's say neural network lang siya, at some point gusto nyong baguhin yung model na gagamitin nyo, why not, yung application nyo, you let it interact to an AI model interface, and you define a predict method, then let those concrete classes implement that method. And let's say we have two models, neural network linear regression, and if you want to add another model, let's say decision tree model, you can easily do that. And yeah, that would be all for this video about abstractions. And if you have any questions, just leave it in the comment section, and I'll see you guys in the next videos. Bye-bye.